So this is Atlas Systems actual submarine. So we want to have Mackay and Isaac run you through how it actually works and all the work that's been put into it.
Alright, so Mackay has done what's essentially the whole outside of the submarine, so he can talk about all the features of it.
Yeah, so almost everything you see on this sub was created in CAD, computer-aided design. So it was 3D designed and then 3D printed. So for example, this nose cone is 3D printed. And then some of the features we have on our submarine are a camera in the front nose cone, which then gets streamed to a screen here so that we can pilot it effectively. We also have a vertical thruster system, which allows us to dive and raise our sub, and we're easier than a ballasting system, which has never been done before. We also have this top sail here, which helps the submarine to stay upright. And for our thruster, we have a gimbal system, which allows us to launch the sub in any direction we want.
Alright, and so for the insides of the submarine, got a lot going on, but so in the front we have a camera which allows us to see where we're going under the water, and then we have this waterproof enclosure, as electronics don't go well with water. So in the front here we've created our own battery system, which is essentially the same as what you'd find in an electric car. So we've created our own there. And then we've custom designed and made our own circuit board, which is essentially what you would find inside the computer, which is a whole bunch of wires that are squished down into a small space. So that's our main brains of the submarine. So how it will work, how it gets the signals from our controller and makes it move in certain ways. And then we've got all the wires which go through special waterproof connections into our pressure hull, which connect to all the different motors and thrusters and all that. Throughout the submarine, we've got these pool noodles and lead weights, which in submarines you have to have it neutrally buoyant, which means it doesn't float or sink. It kind of just sits in the water. So we need that to help us. That makes it easier to navigate and move the submarine throughout in the water.
Up floating on top of the water, we've got this, which just looks like a container with pool noodle, but we call this a satellite, and this has all our receivers. Because signal doesn't travel well through water, we have to have this floating on top of the water while the submarine goes underwater. And what that does is it sends the video signal to our controller, and it also takes the signal from our controller so that we can pilot our sub.
So essentially the reason why we created and designed this circuit board is so there's no wires going around everywhere. So instead of having wires going from point A to point B, they're all just in a really small board, which allows us to just put our components on top, and then there's no wires, so it can't disconnect, and it all just kind of works. So we have this little component here, which is called an RX receiver. So it takes the signals from our controller and it converts that into a signal that our thrusters and servos can understand. And then so here this blue part here is called an Arduino, and so this is essentially the brains of the submarine. So it can take an input from the controller and make the submarine's thrusters move up or down depending on the signal that it's getting. Over here we have a couple sensors. So this here is a gyro / accelerometer, this is a sensor which tests the tilt of if the submarine's tilting or not. So it can tell if it needs to correct itself, if it needs to push itself up in one direction so it stays flat. We have a couple wire connectors over here, so we can easily unscrew them and take them out if we need to service this or change something. We've got a couple lights here so we can tell if it's working or if it's on. And then we've got a couple other components such as a switch here so we can turn it on and off. And then a bunch of other components down there for the thrusters.
And that switch is a magnetic switch, so rather than actually just flicking or pressing a button, we just put a magnet on it and it will actually turn the entire system on.